So what is the pop function? So this function will pop the first element of the list at the left. Basically, if the list is empty, we just print an error and return. If it is not empty, then we're going to have to copy the value into a newly created variable called value. And then we're going to create a list node pointer that points at the head. And then the head gets its next. So it'll be something like this. Okay. So we have here our list. So we created a new pointer called ln that points to the first node, and then the head takes the next. Okay, so it takes the next of the element that is pointing at, so the head will be pointed at this node, and then the previous of this node would be equals to null. Okay. So the previous of the element pointed by head will equal null, and then basically, of course, this line should be after changing the head. Okay. And then finally, we have to free the node. We have to remove the node from the memory, decrement the size of the list, and just return the value. So let's see if that works. So we're going to pop front from the list, and this should print a working list. Well, there's some error here, and so I'm going to fire up the debugger and see what is going wrong. So here I have added a breakpoint here, and let's start analyzing the code line by line. So the error here is in printing. So here, of course, we're going to have to add another exception, which is basically if there's only one element in the list, then we're going to have to set both the head and the tail to null. So let's do that. So if the list size equals 1, then we're going to have to empty the list. Of course, I'm going to here just take the value declaration and copy there, and let's take that also there. And here the size gets decremented, and basically both the head and the tail gets null. And then we're going to free the L head. The head or the tail, it's basically the same thing, but of course we're going to have to free it before setting null to that node. And then after that, we're just going to return the value. So let's see if that works. And as you can see, it works. Okay. So these are our elements. That's 8, 3, and 4. And of course, they are printed in the flipped order, reversed order, because we're pushing to the front and then we're popping from the front. So this basically the principle of stack. Okay, that's the last in, first out. So the final thing that we have to change here is the pop back list. We have so this function will remove the last element of the list. So previously with the simply linked list, we used to iterate through the list to find the address of the last node and then to free that last node after copying its value and return that value. Now we're not gonna do any iteration since we know the address of the last node, which is stored at the tail property of the list data structure. So of course, if the list is empty, then we're going to return 0 and print an error. So we're trying to remove an element from an empty list. So that should generate an error. Otherwise, we're going to see if the list has only one element. So basically, I'm going to remove everything from here, and let's rewrite the implementation from scratch. So if the list size equals 1, it means that the list has only one element. Then basically, I'm going to, let's copy the value here. So that's value equals the list head. Well, that's the list tail value. And then if the list size is 1, then we're just gonna free the list tail or the list head. It's basically the same thing, because since the list has only one element, that means that both the head and the tail points to the same list node. They point to the same node, so basically the same thing. So list tail, we're gonna free that. And then both the list head and the list tail, both of them becomes null. And the size of the list becomes 0. So it gets decremented. And of course, we're going to have to return that value. Otherwise, if we did not return, if the list size is bigger than 1, okay, if it's bigger than 1, in that scenario, we're just going to have to mark the address of the tail of the last node, and then we're going to update the address of the tail of the data structure, and then we're going to free that. So let's do it. So we're going to create a list node pointer that points to the list tail. Once we have a backup of that, we're going to decrement the list tail. So it takes its previous, and then the list tail, which is the new tail, its next becomes null. And finally, we're going to have to free our list node, and then we're going to have to decrement the size of the list and then return the value. So let's test whether that works or not. So I'm going to change this to back, and I'm going to run the code. And as you can see, it works pretty perfectly. So that's 5, 3, 8. So we add from the front and then we remove from the back. Okay? So basically that's the most straightforward implementation of a doubly linked list. So let's review real quick. So here we have a list node structure, which is just a node that contains 3 elements. The first one is the value, the second one is a pointer pointing to the next list node, and another pointer pointed to the previous list node. And then we have a list data structure, which is basically the data structure that contains where the lists start and where the list end and the size of the list and pretty much any information related to the list. Okay? And then a basic function which creates list. Basically, it creates it allocates memory for one list, and then it assigns its head and tail to null, its size to 0, and then it returns its address. And then we have another function that checks where the list is whether a list is empty or not. So it basically compares its size to 0. If it is equals, then it's empty, otherwise it's not. And then we have a push front list function, which takes the list and a value, and of course it allocates memory for one list node, and then it assigns its value. Both its next and previous gets initialized to null, and then if the list is empty, then both the head and the tail takes the address of that newly created list node, and then the size gets incremented, and then we return. Otherwise, if the list is not empty, then we're going to have to put the next of that newly created node to be the address of the element of that the head is currently pointing at, and then the previous of that element, of the element that the head is pointing at, its previous property becomes the address of the newly created node, and then the head gets updated. So it's not pointed to the element that it was pointing at, it'll point to the newly created node. And of course the size gets incremented. And then we have pushback list function, which takes the list and the value, and it creates one list node. It initializes its value. Both the next and the previous pointers gets null, and then if the list is empty, of course, both the head and the tail takes the address of that list node, and the size gets incremented and it returns. Otherwise, the list node previous takes the address of the element that the tail pointer of the list is currently pointing at, and then that element that the tail is pointing at, its next, gets the address of ln of the list node, the newly created list node, and then the tail gets updated to point at the newly created node, list node, and then the size of the list gets incremented. And for the pop front list, basically we check if the list is empty, then we just print an error. We cannot delete from an empty list. Otherwise, we create an integer value which takes the value pointed at pointed by the head pointer, and after saving the value, we just save the address of that node that we're about to delete, and then if the list size is 1, it means that the list will become empty, which means that first we're going to decrement the size of the list, and then we're going to free the element pointed by the head. The list node will be deleted, it'll be destroyed, and then the list head pointer takes null, as well as the list tail pointer. So both of them become null, and then finally we return the value. Otherwise, if the list size is bigger than 1, then basically we're just going to have to increment the head. So the head will take its next, and then the previous of the new head gets null, and then we're going to free that list node that we have copied it before, and then we decrement the size of the list, and then we're going to return the value. And then for the pop back function, we have a list pointer. So if the list is empty, again the same thing here, we just copy the value. If the list is empty, then basically the same thing there, and then we just copy the address of the element pointed by the tail pointer to the list node, and then the list tail becomes its previous element, and then the next of that new tail becomes null, and then we're going to free the element that we copied before, the element that we wanted to destroy, and then we decrement the size. And basically here we have the main function to test all the previous functions. So we added element from the front, and we kept adding elements from the front, and then we popped elements from the back to see whether they work or not. So let's add here adding pushing from the back to see if pushing from the back function worked or not. And as you can see, it works. So we're adding from the back 5 and then 3 and then 8, and then we're removing from the back. So both push front, push back, and pop back are correct. So basically that's it for this video. See you next time.